For thousands of years, humanity has gazed upward, seeking energy from the skies above. We've learned to harness the restless wind, capture the radiant power of the sun, and even collect the life-giving rain. These forces have shaped civilizations, powered our homes, and inspired our dreams of a cleaner, more sustainable world. Yet while we've looked to the heavens, we've often overlooked the extraordinary power that lies just beneath our feet, a source of energy as old as the planet itself. Deep within the Earth, the core burns with unimaginable heat, radiating energy outward through layers of rock and stone. This is geothermal energy, the planet's own natural warmth, a force that has shaped continents, driven volcanic eruptions, and sustained life for eons. It's a reminder that Earth itself is alive, constantly moving and changing with a hidden fire that never sleeps. For generations, we believed this power was only accessible in rare, dramatic places where volcanoes roar, geysers erupt, and hot springs bubble to the surface. These wonders drew explorers and scientists, but seemed out of reach for most of the world. But today, a quiet revolution is underway. Advances in science and engineering are changing everything we thought we knew about geothermal energy. Geothermal is making a remarkable comeback, not as a niche solution for a few lucky regions, but as a potential cornerstone of our global clean energy future. Its promise is growing, and so is our ability to tap into it. The real breakthrough isn't in discovering new heat, but in unlocking new human ingenuity. Engineers and scientists are adapting technologies from oil, gas, and mining, using advanced drilling, digital monitoring, and innovative materials to reach deeper and hotter resources than ever before. These new tools allow us to access the Earth's warmth in places once thought impossible, bringing geothermal energy to cities, towns, and industries around the world. The barriers are falling, and the possibilities are expanding. As our world's energy demands continue to soar, we face a critical challenge: finding power sources that are not only clean, but also constant and reliable. Solar and wind are vital, but they depend on the weather and the time of day. Geothermal stands apart. It's always on, day or night, rain or shine, providing steady 24/7 baseload power that can anchor a renewable energy grid. This makes geothermal the missing piece in our quest for a stable, zero-carbon grid. It can fill the gaps left by intermittent renewables, ensuring that our lights stay on and our industries keep running. Today, geothermal provides less than 1% of the world's energy, but its potential is vast. Some experts believe it could rival or even surpass solar in the decades ahead, if we invest in the right technologies and infrastructure. We now stand at the threshold of a new era, one where we look down not just for minerals or fossil fuels, but for a clean, inexhaustible planetary power. The dawn of geothermal energy is here, and it could change everything about how we power our world. For decades, geothermal energy was limited to geologically active zones, places like Iceland or California. If you weren't on a hotspot, geothermal was out of reach. But technology has shattered these limits. The heat is everywhere. Drill deep enough and you'll find it. The challenge was creating the right conditions: permeable rock and water. Now, new tech lets us engineer these conditions, making geothermal possible almost anywhere. Techniques from oil and gas, like horizontal drilling and hydraulic fracturing, are being repurposed for clean energy. This means geothermal is becoming a universal resource, accessible to communities worldwide. The age of engineered geothermal access is just beginning. At the heart of the geothermal renaissance are three breakthrough technologies, each pushing the boundaries of what's possible beneath our feet. These innovations are not just incremental improvements, they represent a fundamental shift in how we think about tapping the Earth's natural heat for clean, reliable energy. First, enhanced geothermal systems, or EGS. In places where natural geothermal reservoirs are scarce, engineers use advanced drilling and fracturing techniques to create artificial reservoirs deep underground. By injecting water into hot, dry rock, they generate steam that can be harnessed to produce electricity. This approach opens up vast new regions for geothermal development, far beyond traditional hotspots, and could dramatically increase the world's clean energy supply. Second, closed-loop systems. Unlike conventional geothermal, these systems use sealed pipes to circulate a working fluid underground. The fluid absorbs heat from the surrounding rock without ever mixing with it, eliminating the need for fracturing and minimizing water use. This makes closed-loop systems especially attractive in areas where water is scarce or environmental impact must be kept to a minimum. They offer a clean, controlled, and highly scalable way to tap into geothermal energy almost anywhere. Third, superhot rock technology. By drilling even deeper, into zones where temperatures soar far above those of conventional geothermal, we can access supercritical fluids, substances that are neither liquid nor gas, but something in between. These fluids carry immense amounts of energy, potentially enough to rival the output of the world's largest power plants. Superhot rock could unlock a new era of ultra-efficient, high-output geothermal energy. These three innovations aren't in competition, they're complementary tools, each suited to different geologies, climates, and energy needs. Together they form a flexible toolkit that can be adapted to almost any region on Earth, from volcanic zones to stable continental interiors. EGS, closed loop, and superhot rock together have the potential to turn the entire planet into a vast, untapped reservoir of clean, renewable energy. No longer limited to a few lucky locations, geothermal could become a truly global solution. From revitalizing aging geothermal fields to creating entirely new ones in previously unusable rock, these advances are expanding geothermal's reach and impact. They're making it possible to bring clean energy to places that once seemed impossible. It's a testament to human creativity and determination in the face of global energy and climate challenges. Engineers, scientists, and inventors are working together, pushing the limits of technology to build a more sustainable future. The geothermal toolbox is expanding rapidly, filled with new ideas and solutions. With every breakthrough, we move closer to a world where clean, reliable energy is available to all. Each of these technologies brings us a step closer to a future powered by abundant, everlasting energy drawn from the Earth itself, a resource that never runs out. The geothermal revolution is underway, and its impact is only just beginning to be felt around the world. What was once theory is now reality. Next-gen geothermal is powering communities today. In the US, Fervo Energy's Project Red in Nevada delivers constant clean electricity to Google's data centers and the local grid. Fervo's next project, Cape Station in Utah, aims for 400 megawatts, with drilling times and costs dropping rapidly. In Germany, EVER is building a closed-loop system to provide both electricity and heat for thousands of homes. Quaise Energy is developing high-frequency drilling to reach superhot rock, with field tests set for Texas and Nevada. These projects prove geothermal's comeback is real and accelerating. They are the first steps in repowering our world from within. The world's tech giants, Google, Meta, are driving geothermal's resurgence. Their data centers need constant, carbon-free power, something solar and wind alone can't provide. Geothermal's 24/7 reliability makes it the perfect partner. Google's deal with Fervo Energy was a landmark, showing corporate leaders see geothermal as essential. Meta is following suit, partnering for baseload geothermal and even exploring geothermal-based energy storage. These aren't just green gestures, they're business moves that de-risk projects and accelerate deployment. Big tech is anchoring the market for clean, firm power, helping to build a resilient, decarbonized economy. Geothermal's momentum is global. Germany leads Europe with dozens of plants and rapid policy reforms to speed growth. Kenya gets half its electricity from geothermal and is adopting next-gen tech. Indonesia and Turkey are scaling up, backed by strong investment and policy support. Countries are tackling geothermal's unique challenges, high upfront costs and drilling risks, through creative incentives and new laws. Vietnam and the Philippines are launching new models to attract investment and de-risk projects. The International Energy Agency projects geothermal could grow 50-fold by 2050, transforming it into a global energy titan. The world is awakening to the power beneath its feet. Geothermal is a gentle giant, powerful, yet with a tiny environmental footprint. Its energy density means less land use than solar or wind. Most infrastructure is hidden underground. New technologies minimize water use and avoid chemicals, making them ideal for arid regions. Closed-loop systems are fully contained, using negligible water after setup. Concerns like induced seismicity are addressed with strict protocols and careful site selection. Geothermal produces virtually no greenhouse gases, operates quietly, and stabilizes the grid. It's a power source that respects landscapes and ecosystems. Geothermal is clean, reliable, and kind to the planet. Geothermal's future is bright, but challenges remain. High upfront drilling costs and financial risks make financing tough. Regulatory hurdles slow projects as laws weren't designed for next-gen geothermal. Technical challenges, like drilling deeper, faster and cheaper, require ongoing innovation. More open subsurface data would reduce risk and speed growth. Yet costs are falling, regulations are evolving and investment is surging. Governments and industry are working together to clear the path. The momentum to solve these challenges is undeniable. We stand at a turning point, able to power civilization with clean, sustainable energy from the Earth itself. For the first time in history, we have the technology and the vision to harness the planet's own heat on a global scale, transforming how we live, work, and connect with nature. Geothermal is the planet's constant promise, reliable, enduring, and ready to anchor a green future. Unlike other renewables, it's always on, providing a steady flow of energy day and night, through every season, no matter the weather. The last few years have seen costs plummet and projects come to life worldwide. New drilling techniques and advanced materials have made it possible to tap into geothermal resources in places once thought impossible, opening doors for communities everywhere. Imagine cities heated by Earth's warmth, industries powered by constant carbon-free electricity, and grids balanced by geothermal's steady output. Schools, hospitals, and homes all benefiting from energy that's as clean as it is dependable. This isn't fantasy, it's the future next-gen geothermal is making possible. Visionary engineers and scientists are pushing boundaries, turning what was once a niche technology into a cornerstone of tomorrow's energy landscape. It's a homecoming, humanity tapping into the forces that shaped our world. By working with the Earth, not against it, we're rediscovering ancient wisdom and blending it with modern innovation. The heat that once forged continents can now power our dreams, without harming our climate. This is energy that leaves the air clear, the water pure, and the land unscarred for generations to come. Geothermal's epic comeback is a story of hope, innovation, and a deeper connection to our planet. As we look ahead, we see a world where the Earth itself lights our cities, warms our homes, and inspires us to build a truly sustainable future.